Thank you for having me. It's so excited to be here and I'm looking forward to meeting you all throughout the rest of the day. So yes, I'm going to be talking about observability specifically in JavaScript today. And I'm also going to talk about, obviously, as Joe mentioned, the tools that we're going to use. So real user monitoring, synthetic monitoring, and OpenTelemetry. So if you don't know what those are now, you will by the time you walk out of the room. And we'll also talk about the different types of signal that we basically can use to diagnose issues in applications and where I would use one over the other. So firstly, I've introduced myself properly. I don't need to go through this again. We will have time for questions on this QR code, but if you want to catch me afterwards and you're like, I don't know where Carly is. Carly is all over the place on the interwebs and I've lost track. I'm collecting social media like Pokemon right now. So if you would like to connect on LinkedIn, X, Mastodon, Blue Sky, wherever you are, just scan and find me there, okay? Obviously, we're taking questions via the app today, so if you've not got it on your badge, which I think everybody should have, or you're on the live stream and you want to ask questions as you go, there's the QR code there. But let's talk firstly about the different types of information that we can use, some of which I didn't have access to when I was a front-end engineer all those years ago, but others that we should be familiar with now. So the first type of signal that we can use to diagnose issues in our application would be logs. So daft question, who is using logs in their application? Put your hands up. I'm slightly worried that not all the hands are up, but that's fine. But we all know what logs are, right? Logs are these structured error messages. Now, obviously in the JavaScript ecosystem, we've got front end and back end considerations. So in the front end, normally it's structured error messages or warnings or information that we spit out into the browser, which can be a challenge because obviously if these are errors that are manifesting on a user's machine, we might not always have access to them. So when I was an engineer, I used to work at Morgan Stanley, and I, in some ways, was quite lucky because I could literally run down 2 flights of stairs and go and stare at the DevTools console on my user's machine or ask them to send me a screenshot. Sometimes we don't have access to this information and we need to find tools that can capture the error diagnostics and also other useful information such as the user agent, like the time I found out that my user had a really wacky error because they were using Internet Explorer. I'm hoping those days, does anyone have to still support Internet Explorer? Normally I get one. No? Great, okay. Normality is restored. But then also if we think about the back end side of things, we will probably be logging to a file somewhere and then that might be swept up and put into an observability platform like ElkStack or something else. So this is an example here where you would use Winston, which is effectively going to use a file beat, which is just basically a simple lightweight process that will scrape a file and send it to, an Elastic cluster in this instance. So you have examples where you can actually send logs on the backend service quite easily to wherever it needs to go. Now the second thing is metrics. So who knows what I mean by a metric in observability terms? Not that many of us. Okay, that's good. That's why we're here. So by metrics, I'm meaning quantifiable measures that we can track over time to see how our application changes and evolves and if potentially it's starting to degrade or if a problem is appearing. So when we think of front-end measures, one of the primary ones we should think about is Core Web Vitals, which was mentioned in the keynote this morning. So in the keynote this morning, did anyone look and go, I don't know what they mean by Core Web Vitals? Safe space. Everyone knows what Core Web Vitals are. Okay, so we are going to fly through this really fast. So when we think about Core Web Vitals, there's the 3 primary ones that we want to talk about. So you've got largest contentful paints. Now why that's important is because we want to have a good initial loading experience. Think back to the keynote this morning. We're talking about the idea of, hydration and how we want to give the user immediate feedback that the application is doing something and it's not just spinning on its heels with a blank screen while we're waiting for different assets to load. So LCP is important for that consideration. And if your LCP is starting to take longer and longer, possibly as a result of changes you're making in development and you're not tracking those, or you're not identifying in production that they're starting to take longer and longer, then obviously that user experience is degrading. It's also going to potentially degrade if we think about reactivity. Now with first input delay, we're not going to talk about first input delay because it's deprecated. It was deprecated in March of last year. If you're using it, switch to interaction to next paint instead. But basically you get the idea of the app needs to be responsive as well. If However, the amount of time we're taking to respond to user input is getting longer and longer as well. That's not a great experience for a user. Okay, that's normally when we start trying to diagnose particular performance issues. That was when I was a front-end engineer. A lot of the time, the problems are coming to me first because either the app wasn't responding to their input, which is legitimately down to a front-end issue, or sometimes I was getting, oh, the numbers aren't right. This page isn't loading. And it wasn't always me, but I was the conduit because users, and I quote, think everything's the front end because that's the attribute they can see. The complexity of the systems that I was historically dealing with was I was getting numbers from all sorts of different services, microservices hopping around on the back end. So being able to see exactly where using different measures is quite important for me. And then the last one is cumulative layout shift. Is everyone familiar with cumulative layout shift and why it's important? I.e. not selecting the wrong option and then wondering why, we've accidentally paid for something we didn't want to because the buttons moved or connecting my son's headphones to the wrong device and then he ends up hearing the TV rather than, the iPad. These things are all really important from an observability standpoint, and that's why we need to track them. So historically, we would use tools in the browser, such as Google Lighthouse. So we're all familiar with Lighthouse in the browser. In fact, we can run them in other places like CI pipelines, track it over time. We can run it quite often against hosting services like Netlify and all these different places. It's a good tool for an indication and trending over time, but one of the limitations with it is it's based on synthetic traffic. So it's not actually giving you an insight against a production app what a user's actually experiencing. And that goes the same for any kind of stats that are not core web vitals but are additional ones captured by Lighthouse, so those things like blocking time and speed index, etc. We've also got the notion of the node backend side, which is basically CPU and memory, ones that we would obviously want to track. And that's still quite important because obviously if we're having a service under strain, that's going to still replicate in the front end as well. Now, the last type of signal that we have is traces. So who's familiar with what a trace is? Okay, some, but not all of us, so that's cool. So what I mean by a trace is the pathway of execution. So I'm using the CNCF OpenTelemetry definition, and we'll talk about what OpenTelemetry is later. But you've kind of been using tracing, if you think about it, and not even realizing it. So who's familiar with the network screen that I've got up here? Yeah, we all are. We've seen it. We use it. Think about what this is. This is showing us the pathway of basically how long each of the request stages are with regards to getting the assets. So it shows us how long each is. It's showing us the dependencies. And we can therefore establish a picture of how long that content is taking to load. But when we think about tracing, when we look at kind of across an entire JavaScript application, you want to see into the layers. You want to be able to see what portion's the front end, what portion's the back end. Well, I did, at least when I was always on production support and being asked, oh, why is this taking too long? It's because this service over here is down. So what you can see in the example above is the total call that I've got for the records page, okay? Oops, go away. And then you can see underneath, this is the actual JavaScript service underneath, where I'm seeing how long each individual step is calling. And when you're trying to diagnose performance issues, one of the first things you have to identify is where is the problem. If you're working in a complex ecosystem with numerous micro front-end elements and numerous microservices and perhaps a few databases and live real-time infrastructure like Kafka thrown in there, you kind of need to start thinking about where the bottleneck is, and that's where these type of tools can help you establish that. So diving into tools, the first one we're going to talk about is RUM. So I'm not talking about the favourite beverage of pirates, it's a bit too early to go to the bar. What I'm talking about here is real user monitoring agents. So guess a quick show of hands, who uses a RUM agent at the moment? Not that many of us. Okay, that's cool. So what a RUM agent is it's a dependency that you introduce within your JavaScript application. It's going to capture some of these telemetry traces that I've just talked about. So it's going to pull in the errors that you're going to find within the DevTools console on a front end. It's going to be able to pull in things like page load and core web vital calculations. And it's also going to be able to pull in that tracing information, particularly in relation to the assets we care about on the front end. So not just seeing how long the JavaScript's taking to download and load, but also other assets. So if you've got images that are taking too long because you've not optimized the loading for that, you're going to be able to see how long each of these assets are going to be able to load within tracing. Now, you're probably thinking, well, you're showing me a vendor-specific thing. I want something open. So is anyone using Boomerang.js, which would be an OpenRUM agent implementation? Nobody. So we're probably using some form of vendor-specific tool. Now, when it comes to an open alternative, the one that I see coming on the horizon would be OpenTelemetry. So who's familiar with OpenTelemetry? Yay, good! I've been to a few JavaScript conferences and there's no hands, so it's really nice to see hands for OpenTelemetry. So for those who are not familiar, it's a CNCF sponsored project. It's a huge, thriving developer ecosystem that provides tools and technologies for capturing the type of signals that I've just been talking about. And they provide SDKs for numerous languages, including JavaScript, which is the documentation you can see above. Now, what I'm going to point you to with regards to client instrumentation is the big red banner up there that says client instrumentation is experimental and mostly unspecified. So if you're wanting to do something in production with regards to capturing these metrics, at the moment, you're not able to do that. If you wanted to go down the route of capturing Core Web Vitals on their own, perchance, you can. We'll get to that in a minute. But with regard to the state of the OpenTelemetry ecosystem for page load and Core Web Vitals, which are the two things I've just said we should be tracking, both of these are actually under progress, as you can see from their board. So if you're interested in this, if you want to contribute, go contact the SIG. I'm sure they'd love involvement. But for the moment, if you wanted to do this yourself for just Web Vitals, i.e. without a RUM agent, you can see where this is going, you'd probably need to use the Web Vitals library yourself. Now, I have been playing with this. I haven't got it working quite yet. It's on my list. But what you can see here is this is an example snippet. So we use Web Vitals to basically trigger on the LCP, IMP, and CLS metric events, okay? And then within my instrumentation base, when I capture each of these events, I'm using this report utility, which is going to create, using a web provider, a span. So we're going to get the top level tracer, and we're going to get basically create a span with the appropriate attributes for each measure, and then send it wherever we want to send it using an exporter. That's how it would work in theoretical terms. But going back to the RUM again and how you would do this in comparison without Core Web Vitals on its own, there's normally two ways to do it. So you can either include it via script tag in the HTML, and the reason you might want to do this is if you have a really old application that you're scared of touching, and I've had to maintain a few of those. So what you would do in this instance is add the script tag to the top of the HTML, and then you would initialize it. Now the two attributes you're going to, at a minimum, specify is going to be the service name, so a unique name for this UI, which is important if you're thinking about micro front-end architectures, or you're thinking about, hey, is it the front end or the back end that's causing this issue? I need to know which component it is. And then you've got the service URL, so basically where am I sending the data to? But obviously that's probably not what we want to do in this regard, okay? We're probably going to want to instrument an SPA application written in React or our own vanilla JS. And what you would do in that regard is install the appropriate RUM agent and then initialize it in the entry point. So obviously in a React example, it would be the app.js. So obviously we've talked about what service name and URL are. Optionally, adding in additional variables so you can see what's going on and be able to compare is quite important in a production outage scenario. So let's take the example that my husband had 2 weeks ago, where something was happening in production and they didn't know why. There was two things that he was immediately wanting to check. One, is it as a result of a new change? So being able to compare using the version attribute in a service is actually quite important in that regard, because that means that you can then say, oh, well, hold on a minute. This wasn't in version 1.2, but this was in version 1.1. And that might help you narrow down what's actually causing that particular problem. But also, we've all had that situation in production of, did I see this in non-prod? I'm not sure. And you need to be able to check that. So perhaps having a situation of being able to compare environments is also important. So you can compare all of the stats that we're talking about. But also compare the tracing for particular pages and endpoints and see what's happening is also quite important. And then distributed tracing origins, because this lovely thing called cores that we all know and love, right? By default, an agent's going to run on a single origin policy for very good reasons. But if we want to connect the front end and the back end tracing, what we need to be able to do is basically connect those pieces together. And the way that that's commonly done is through the W3C standard of the trace parent header. So when you specify distributed tracing origins in this example, it's going to add the trace parent header onto the HTTP request so that you can basically connect things as you go. Now, the last thing we need to think about is SPAs. Is there anything customer specific that might not be captured? And if so, is there an extension on an agent that I need to therefore leverage? And this would be an example here where we use the React extension on top of React Root or DOM. So what it's working in simple terms is basically taking the APM roots component, and instead of wrapping in roots, which would be the vanilla version of the latest version of React Root or DOM, you would wrap it in APM roots instead. Now, this might seem a bit weird. Why am I referencing the documentation? One of the biggest gotchas with adding any dependency, but specifically for RUM agents, is you could be adding something with considerable size, which is going to impact the JS bundle size. And it's going to feel really ironic and silly if you don't optimize your production build and you end up in a situation where the RUM agent is causing a performance issue and taking a long time for your app to load. We're all going to feel a bit silly in that regard. So what we need to make sure is that we're following the instructions for optimizing the production build correctly so that we don't end up with this weird situation of the agent I introduced to identify performance bottlenecks and issues is causing performance bottlenecks and issues. And I have a really funny story where App Dynamics actually did that in a live production application, if anyone wants to come and ask about that later. Not that App Dynamics isn't awesome, but you just need to sometimes test these things before you just roll it out. Anyway. So what kind of metrics are we going to get from a RUM agent? Well, we're going to get the core web vitals that I talked about in the page load stats. But other things that are quite useful, as you can see towards the bottom of the page, is seeing the page load duration by region. So we had the talk this morning from Jemima where she was talking about how we can do things that are not in JavaScript and do it another way using things like HTML and CSS. In certain areas of the world where actually people are using older devices in comparison to us, or perhaps where the ecosystem is not the same in terms of network and infrastructure, having a really bloated JavaScript application that's taking ages to load isn't actually the best. It means it's going to be a poor experience for those individuals. And there's actually been some great talks in the JS ecosystem if you search for them on people talking about exactly this topic. So in that regard, you actually want to see things like how long the load is taking, and then also seeing things like the agent and operating system information. If, like me, you've ever had the situation where someone's still using Internet Explorer. And then obviously we talked about tracing. So it's not just about seeing the calls going through the front end and the back end, but it's the assets that we have within the JavaScript application on the front end that I also want to be able to see. So I need to see things like how long are the images and CSS taking to load? How long is it taking to parse the document? Because then I might be able to actually take Lighthouse out and have a look and see what recommendations it's having. And then obviously errors. As we talked about, you don't have access to your user's machine. Maybe the console errors would be a useful thing to see. So now I want to talk about OpenTelemetry, focus specifically onto the Node.js backend side of things. You can obviously use APM agents. So is anyone using like a native APM agent and not OpenTelemetry? Okay, a couple of us. So you can do that. Obviously, the disadvantage of that is that you're locked into the vendor-specific implementation. Meanwhile, with OpenTelemetry, because it's an open community standard, you have the situation where any vendor that has support for it is supporting that, an open version that you can use to swap vendors effectively. So that's kind of the advantage of using a native agent compared with OpenTelemetry. Apologies, the other way around. So when it comes back to OTel for Node.js, that is actually supported, so that's all fine. But one caveat and gotcha we do need to be aware of is traces and metrics are considered stable, so that would mean available for production use, and logs are still very much under development. So you do need to kind of be careful and make sure that according to the SDK that we're in a stable situation. And this does depend on the language. So for example, if I take Java, because I used to do Java backend services as well, that's fully stable in all of these categories. So that would mean it was safe for production use in every regard. When it comes to OpenTelemetry, you've got two options. So for those who are not OTel experts that didn't put their hand up earlier, you can either use automatic instrumentation, which is where it will attach on basically the run using the auto instrumentation register, or alternatively, you can use manual initialization, which we'll show an example in a minute. So once we've basically used the respective installs via npm, what you'll be able to add in is via the environment variable set exactly which particular settings you want for OpenTelemetry. So you've got the resource attributes firstly. So again, I talked about the importance of version and environment and why I would still add these. Those are still there, as is service name. We're utilizing the OpenTelemetry protocol, which goes by OTLP for short. So that's basically the schematic that says as long as it's compliant with this protocol, we'll be able to send the messages through. So you basically specify the endpoint of the vendor appropriate technology that you're sending the OpenTelemetry signals to. In this particular instance, we need to basically specify the headers for authentication, which is why I've got them in there. And then also node resource detectors actually allows you to switch on and off and define which particular types of measures you want to actually capture automatically. So if you don't specify that environment variable, it will send everything by default. Now that can mean potentially that you have signals that you're not interested in, you don't want to use, and that means you're therefore taking up storage to store these signals. So in that particular instance, you might want to think about switching some off. That is how you would do it. And then when it comes to the exporter for traces and metrics, you would specify OTLP with the tiny caveat that there's currently an issue with metrics exporting via environment variables. So in that instance, you'd probably want to initialize manually. This is an example. It's actually taken directly from the documentation. And the way that it works is we use the Node SDK to initialize the OpenTelemetry SDK itself, specifying the exporters that we want for traces and metrics, and then we actually start the SDK, and that will run from that point and capture the appropriate signals. Now, one thing you might be wondering is, well, what about if I want to add my own events on? What if I don't want to just get the default? Maybe there's additional information relating to specific methods that I want to capture. And you can do that in both regards using the API. So I've got an example here, so you can see on line number 9 that I'm getting the tracer associated with the service name. So for this unique service, this resource. And then whenever my records endpoint is being called within my node server, I'm starting an active span, so a custom one here, which will attach to basically the top level tracer. And then it will end after I've sent the request back for all of the records, which looks like this. So you can see here that underneath the GET request, it's actually added this custom span for me in the middle alongside all of the other assets that I can see. It is definitely coming from the server, as I promised, but then also these labels. So this is where all of the attributes, so if you added in custom attributes as well as the default ones like agent, etc., they're going to show up in the metadata for each of these types of signal. Is everybody with me? Cool. We're now going to talk about synthetic monitoring. Now, sadly, I'm not talking about the lovely Pepper here helping you fight crime and, find problems in production. I'm also not talking really in this instance about heartbeat monitors. So does anyone use heartbeat monitors against any services? Nobody. Oh, there's a few nods. Okay. So this is a simple one here that's just going to ping every 3 minutes a given endpoint and say, hey, are you still alive? And hopefully, if everything's all good, our application is going to go, yeah, I'm still alive. It's all good. But actually, synthetic monitoring has evolved since then to use automation frameworks that actually can automate what a user is doing in a user perspective, which is actually quite useful because that allows us to actually say, oh, well, hold on a minute. I want to be able to see if this particular workflow is operating in production, and if it's down, I want to be notified of it, hoping, with any luck, that you manage to catch particular outages and issues before a user starts yelling, which is obviously quite a nice thing to do. There's normally two ways that synthetic monitoring tools allow you to capture these user journeys. So you can either use recorders. So does anyone use recorders for things like end-to-end testing in Playwright or Selenium or Cypress? No, a couple, okay. So recording would be one way, and the way that works is basically the recorder will spin up normally a Selenium or some form of browser instance, and you will basically perform the clicks and it will capture the code artifact. And that can be a useful way to get started. But to be perfectly honest, I prefer writing them as code artifacts myself, and that's where monitoring as code comes in. So that's when you have your artifact actually as, a codified artifact, like an end-to-end test. And what that would allow you to do is basically store it under source control, so you can do smart things. So I'm going to show an example. So I'm going to use Playwright.js. So does anyone use Playwright at all at the moment? Do we all know what it is? I see some shakes and some. That's cool because we're going to cover it. So Playwright.js is a Microsoft maintained end-to-end testing and automation framework. So I'm using it with Elastic, and I'm also going to show you how to run it at 3 points in the lifecycle. When it comes to synthetic monitoring, some are using Playwright and some are using Selenium, and some are recording with their own custom thing. So if you're just wanting to get started with what you have, that's cool. My advice is go and see what is supported by your current observability tool, and that's the best way to get started. So the way that this is going to work is I'm going to have a TypeScript-based definition that is going to be able to run in 3 places. So I can run it on demand against a locally running app, and I can effectively test my monitors and see if these work, i.e. not testing my monitors in production and destroying the universe. I can then run it just like an end-to-end test within a CI pipeline as well as a validation to say, okay, the monitor is working on merge of my changes, this is all good. And then also when you push it, it will run from a location and it will run on a fixed schedule against the production version of the app. And then you'll have the details for each run saying, hey, okay, this particular one succeeded or failed. So this is the little app that we're going to instrument. We're just going to instrument the login, very vanilla login. If anyone's using stuff like OAuth2, etc., the Playwright request parameter is what you want to use to basically simulate that. But I'm not covering that today. If you're interested, come and find me afterwards. So this is an example of the type of configuration that we're going to have. So remember I said we can run this in multiple places. And the reason that we can do that is because we're passing in the node environment. The node environment allows me to tell if it's in dev or production mode, or perhaps any others that you can think of. And within the parameters, by default, it's going to run against localhost, which obviously makes sense for local development. But if we scooch all the way down to lines 34, you'll see that I'm actually able to override it because it's just a TypeScript file. So I'm overriding it, utilizing the URL for my production URL instead. Obviously, this is a very important step. If you don't specify the node environment, it's going to default to localhost, and then you're going to wonder why your monitors are failing against localhost. So just be careful and bear that in mind. The types of parameters that we normally want to pass into these things would be things like your username and password. Use a test account, don't use a prod account. I'm hoping it's obvious why. If it's not obvious why, ask me. And you can also do smart things like maybe you only want to run a subset in production and you have a more expansive set as pre-production checks. Then obviously you can use other logical conditions. Obviously, because it's using Playwright, you can do things like device emulation, which is important for, I don't know, seeing if stuff works in Internet Explorer or Firefox or the things that I had to use to do. So specifying the device options for Playwright is quite important as well. And then you'll normally have to set a schedule. So this will apply by default unless you specify it in the individual monitor. It's going to be 10 minutes. And then obviously it needs to know where to push these, which is where the project settings come in. Now, when it comes to the actual monitor, this is it here. So this is basically a Playwright test with journey and step wrapping stuff on the top. That's the way to think about it. So the reason it's done this way is this is what's called a multi-step. And multi-step is quite important if you think about observability because you need to know what stage is failing rather than that this whole massive user workflow is failing. I'd like to know which individual step it is because that can then help me say it's this particular new feature or it's this particular service that's not available. So what I can do is utilize the page object in Playwright alongside the parameters that are passed in order to perform the actions associated against the HTML elements. So I pull everything out by test ID. Do not pull stuff out by ID or class. If you want to break your suite every time you make a minor change to your appearance of your page, go do that. But I'd rather not. So utilizing the data test ID attribute, which is common practice for end-to-end testing, should be the same thing for monitors. And then we basically do all the things in Playwright that we want to do. We do clicks, we do text entry against the input elements. We check against particular buttons to see if they're disabled and then change to enabled on text entry, all those other kind of things. And when we have that action, we can then run it locally. As I said, you can then run it within a CI pipeline as well. Obviously, that means that you're gating. So you don't want the situation where your monitors get out of sync with code changes. If you have that, same with an end-to-end test suite, that's going to give you a problem. So we don't want that. And then when we specify the node environment and push them with a private key, don't share your key in a public repo. It has to be said sometimes. We can end up with situations where we can see whether a monitor succeeded or failing. You can see how long things are taking, which is quite important, not just from an individual monitor, but also from a step, because if the app's getting slower and slower, there's potentially degradation. It's not just, oh, we added in a new step for the user. So we need to be able to see what the difference is in a production scenario. We need to be able to see errors. And then we also get the measures such as core web vitals, etc., which are quite important. So we're almost out of time, but we've talked about these different types of signals and how you use them in a production scenario to find out what's going wrong and what the state is with regards to each of the tools that we can use for it. If you want to catch me, we might have a minute for questions. So thank you very much. It's been a pleasure. And if not, I'll catch you outside in the hallway.